right, this is 6.1, imaginary and complex numbers. So let's start out by looking at something that we already know, like the square root of 36. So we know when we have the square root of something, that means what number times itself gives you that number inside the square root. Okay, so for this case, what's the square root of 36? That would be 6 because 6 times 6 equals 36, right? But now, for the square root of negative 25, we have a negative inside our square root symbol. And this causes a problem, right? Because positive 5 wouldn't work because positive 5 times positive 5 is positive 25. And negative 25 wouldn't work, or sorry, negative 5 wouldn't work either because negative 5 times negative 5 is also positive 25. Okay? So for the longest time, when anybody came up with a negative inside a square root like this, they would just say, oh, this problem's not possible. They would write no solution, okay? And then many, many years ago, some Greek guy decided he would just invent a number for this, okay? And then years later from that, kind of as a way to mock that guy, another Greek math guy decided that he would call them imaginary numbers as a way to kind of like poke fun at him, like look at these imaginary numbers. All right. Then it wasn't until much later, even still, that another Greek math guy named Gauss started using them, and people started taking them a little bit more seriously. And then further, not until the 19th century do people start coming up some actual real world applications for this. Like we'll get into a little bit later. There's some applications with physics and some electrical currents. So we'll look into some of those later, but I just wanted to give you a little bit of the history on this. All right, so why did this cause a problem? We know that 5 times 5 doesn't work. We know that negative 5 times negative 5 doesn't work. So what we figured out, or what we kind of went with, is that 5i times 5i equals negative 25, okay? And so the key here is to recognize, well, we know that 5 times 5 is positive 5, but I times I equals negative 1, okay? And if we multiplied 25 times negative 1, that's how we get negative 25, okay? So this part here is really the key to imaginary numbers, all right? So that I times I equals negative 1. All right, so how about the square root of negative 50? All right, so this one's not going to work out as nicely because we don't have a number that multiplies by itself to equal 50. So what we're going to do is just call this I times the square root of positive 50, and then we're just going to simplify that radical. All right, so we know that the square root of 50 can be broken down into the square root of 25 times the square root of 2. All right, and the square root of 25 we know is 5, so that would be 5 times the square root of 2. But we don't like to write the I in the front. We're going to write this as 5i times the square root of 2. All right, and that's it. That's as far as we can go with that. All right, so now we're going to look at this a little bit more in depth. So I'm going to zoom in here. All right, so the first thing we got to recognize is that I is just I. All right, and as I mentioned before, I times I, or I squared, equals negative 1. All right, so now then we have I to the third power. Well, I to the third power is really just I squared times I, right? 1, 2, 3. Well, I squared we know is negative 1, and negative 1 times I would make this negative I. All right, and then I to the fourth is really I squared times I squared. Well, I squared is negative 1. I squared is negative 1, so this is negative 1 times negative 1, which a negative times a negative is a positive. So this equals positive 1. Okay? So now let's look at I to the fifth power. Well, I to the fifth you can think about as I squared times I squared times I. Well, I squared is negative 1. I squared is negative 1 times I. Well, negative 1 times negative 1, that's positive 1. Positive 1 times I is just positive I, right? Okay, and what about I to the sixth power? Well, I to the sixth, I'm going to erase this a little bit. I to the sixth, you can think about as I squared times I squared times I squared. All right, so that's negative 1 times negative 1 times negative 1. All right, negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. All right, so what we're starting to recognize here is that this here keeps repeating. So what's going to happen is we're going to keep going from I, negative 1, negative I, positive 1, and we start back over. I, negative 1, negative I, positive 1. All right, so if you're looking for I to the 15th, right, well, we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. There we go. So I to the third, right? So this I to the 15th is going to be negative I, right? So what's a faster way than just counting this out? Well, if we're going through 15 times, well, how many times are we going to go through this list of 4? So we're going to divide this by 4. 4 again goes in 3 times, right? And we have the remainder of 3. Okay, so the remainder is kind of key. So remainder of 3. So we have 1, 2, 3, and that's how we get I to the third power. All right, how about I to the 34th? Well, let's see how many times does 4 go into 34. Looks like 8 times. 3 times 8, or sorry, 4 times 8 is 32 with a remainder of 2. So that means it goes through 8 cycles of 4, right? And then we have a remainder of 2. So that would leave us with 1, 2. I squared is negative 1. So I to the 34th power is going to equal negative 1. All right, what if we have something that goes in perfectly? How about like I to the 40th power? Well, 40 divided by 4 is 10. There's no remainder. That just means it's going to end perfectly at I to the 4th. So I to the 4th would equal, or I to the 40th, sorry, would equal positive 1. All right, now let's look at some equations where we might get some imaginary numbers as our answer. So for this first one, 18 is equal to negative 2n squared. First thing I want to do is get the n squared by itself, so I'm going to divide both sides by negative 2. And I'm left with negative 9 is equal to n squared. I want to get rid of this n squared, so I'm going to do the inverse operation of squaring, which is taking the square root. And if I do it to one side, I got to do it to the other side. So the square root of n squared is just going to be n. And the square root of negative 9 is going to equal plus or minus 3i. Okay, so we introduced the square root symbol here. So anytime we do that, we're going to be left with a positive or negative answer. So for the first example we looked at, it was just, we were finding the square root of positive 36. And so this is kind of just referring to the principal square root, which is just always going to be positive. But when we introduce the square root symbol into our equation, we need plus or minus. So this is definitely something we should pause the video and make note of. Let's go ahead and write this in your margin. When you introduce the square root symbol, your answer will be plus or minus, okay? So this would be plus 3i or negative 3i. All right, hopefully you got that written down. Let's move on to the next one. So we got x squared plus 1 is equal to negative 6. So I'm going to get that x squared by itself. So I'm going to subtract 1 on both sides. And I'm left with x squared is equal to negative 7. All right, now I want x by itself. I just want 1x. So I'm going to take the square root of x, take the square root of negative 7. Now I'm introducing the square root symbol, so I know I'm going to have a plus or minus as my answer. Square root of x squared is just x, and I'm going to be left with plus or minus. There isn't a number that works out nicely for the square root of 7, so we're just going to call this plus or minus I times the square root of positive 7. All right, Easy as that. Last one for today. How about we look at 3y squared minus 2 is equal to, let's go with negative 56. All right, so the first thing I want to do here is get rid of this negative 2. So I'm going to do so by adding 2 on both sides. All right, and I'll be left with 3y squared is equal to negative 54. All right, now I want to get this coefficient in front of y squared out of there, so I'm going to do so by dividing. So I'm left with y squared is equal to negative 54 divided by 3, which is negative 18. And now I'm going to take the square root on both sides. Square root of y squared is y. And now I introduce the square root, so I know I'm going to have a positive or a negative answer. And the square root of negative 18 is not going to work out nicely, so I'm just going to call this I times positive 18. But I can still simplify the square root of 18, so we still need to do that. The square root of 18 breaks down into the square root of 9 times the square root of 2, and the square root of 9 is 3. So we're left with, our final answer here would be y is equal to plus or minus. Remember, we don't want to call this I3. We're going to call this 3I times the square root of 2. So there's your final answer. And I want to show you just on your calculator, in case you are not very good at simplifying radicals. Just want to show you how to do that on your calculator, even if it's just checking your answer. So if we're at this point and we try to let our calculator go from here, we can pull up our radical by hitting the second key and the x squared button. Now, if you try putting in a negative here, your calculator's not going to like that. It's going to give you domain error as your answer. Okay, but if you take care of that negative by pulling out the I and calling this I times the square root of positive 18, your calculator can check that one out for you. So you put in positive 18 and press enter. There you go. It simplifies that for you. Okay, just remember when you're writing this out, you want to make sure it's the number times I and not I. Moving on, now we're looking at complex numbers. So complex numbers are just numbers that have a imaginary part and a real part. Okay, so this A is going to represent the real part, and this BI is going to represent the imaginary. All right, so this is just going to look something like this, 4 plus 2i, something like that. We have the 4, which is real, and then we have the 2i that is imaginary. All right, that's it. So what we can do with these complex numbers is graph them out on the complex plane. So instead of the x and y axis, we're going to have the real axis, which is going to be like the x-axis, and the imaginary axis, which is going to be like our y. Okay, so if I wanted to plot out a point like 4 plus 5i, I'm going to go 4 to the right in the real, 1, 2, 3, 4, and then 5 up in the imaginary, 1, 2, 3, 4, 5. So that's going to be this point right here. That's going to be point A. How about B? I'm going to go back 2 on the real axis, 1, 2, and then down 3 in the imaginary, 1, 2, 3. So point B is right here. How about point C? Point C is just imaginary, just 3i, so I'm going to go up 1, 2, 3 on the imaginary. I'm not going to go to the right or left on the real axis. All right, so this would be C. Could we plot a regular number here? Sure, we could go, let's go negative 4. This would be a real number, right? So I'm going to go back 1, 2, 3, 4 on the real axis, and I'm not going to go up or down because this isn't imaginary at all. All right, let's look at a couple examples here. We have negative 25 is equal to n minus 1 squared. So the first thing we want to do is get rid of that power of 2. So we want to take the square root of both sides. All right, and I'm introducing the square root symbol, so I know my answer is going to be plus or minus, right? So we know that the square root of negative 25 is going to be 5i, and on the right side, I'm just going to be left with n minus 1. All right, but I still need to get my variable by itself, so I'm going to go ahead and add 1 on both sides. On the right side, it's going to cancel out. I'll just be left with n. But I want you to think about these two terms as not being like terms, so I can't add them together. So I'm just going to have to write the 1 off to the side here. So this is going to be 1 plus or minus 5i. All right. The second one here, before I take the square root, I need to get rid of this positive 8. So I'm going to subtract 8 on both sides. And I'll be left with x plus 3 squared is equal to negative 2. All right, now I can take the square root of both sides. So I'm left with x plus 3 is equal to, this is not going to work out nicely, so we're just going to be left with plus or minus I times the square root of 2. All right, and now I need to get the variable by itself, so I'm going to go ahead and subtract 3 on both sides. And I'm going to be left with x is equal to negative 3 plus or minus I times the square root of 2. All right, we got one more. All right, let's say this equation is equal to negative 1. All right, so we've got a few things we need to do before we start taking the square root. First, we need to get rid of the positive 7. Then we need to get rid of this 1/3. All right, so the first thing, I'm going to get rid of the positive 7 by subtracting 7 on both sides. All right, so I'm left with 1/3 times y plus 2 squared is equal to negative 8. All right, now I want to get rid of this 1/3, so I'm going to multiply by the reciprocal, 3 over 1, and that's going to cancel out. I do it to one side, I need to do it to the other side. So now I'm left with y plus 2 squared is equal to negative 8 times 3, which is negative 24. And now we can take the square root of both sides. All right, so on the left side, I have just y plus 2. And on the right side, I can call this I times the square root of 24. Let's scoot this down a little bit. Oh, and I forgot my plus or minus out in front of here. Okay, so I can break down the square root of 24 into the square root of 4 times the square root of 6. The square root of 4 is 2, so we can simplify that, times the square root of 6. Again, if you're not, if you want to check your answer, you can always bring up your calculator. Square root of 24, okay, 2 times the square root of 26, we did it right. All right, now let's drop everything else down here. So we had y plus 2 is equal to plus or minus I. Okay, so a couple things. First of all, we remember we need to switch the order here. Okay, so let's just do that now. Plus or minus 2i times the square root of 6. All right, now I need to get the y by itself, so I'm going to subtract 2 on both sides. And I'm left with y is equal to negative 2 plus or minus 2i times the square root of 6. So you get some goofy answers here, but that's okay. All right, but that's all I have for you guys today. So give these practice problems a shot. If this is new to you and pretty confusing, that's okay. Just come see me or Google Meet with me. All right, good luck.